Hello everyone. This is Abilino Dawes, your instructor. Before proceeding to the next lecture on rotor angle stability, okay, we will discuss first, okay, the turbine generator control so that we will have a good grasp on how the turbine and our generator operates. Now, our turbine generator are controlled by two channels. Okay, the first one is the power frequency control channel, which is on this part of this block diagram. And then the second is about the reactive power and voltage control channel, which is on this okay part. Now, on the power frequency controller, we have okay two inputs. Okay, which is delta Fi and the other one is delta P tie. Now, okay, these two inputs are coming, the delta Fi is coming from our generator while our delta P tie, okay, comes from, okay, the rest of the network, no? For example, because our generator is not operating alone, but it is connected to the system. So this delta pita here represents okay the change in power okay that the generator this generator need to generate okay to okay further contribute to the operation of the system. Now because at any time as we have seen okay for steady state operation of our power system. Okay, the total generated power should always equal to the total power demand and the total losses at that particular moment. So, any changes in the system would therefore has a share okay, for each of the generator being connected. So, this delta pita here represents okay, the uh, change in power that this okay, generator needs to generate okay, more than what it has generated okay, at steady state. No? Okay, so uh, for the frequency, okay, we need to connect our frequency sensor okay, to one of the terminals of our generator. And then the actual frequency generated by the generator okay, is compared to the standard frequency which is set at the frequency sensor okay, at 60 hertz. Now, any difference, whether positive or negative, will be the output of this frequency sensor. Now, for example, the frequency here is 59 hertz and the actual is, and the standard is 60. So, this delta F here is the actual minus the standard. So, it is 59 minus okay, 60 hertz. So, we have here a negative delta Fi. Now, if the frequency here is higher than 60, for example, 61 hertz. So, we compare that to the standard. So, actual minus the standard. So, we have 61 minus 60. So, we have 1 hertz. So, our delta Fi would be, okay, positive. Now, this delta Fi will then be fed to our PF, okay, controller. Now, in the PF controller, when there is also a value of delta p tie, now that's coming from the rest of the system, okay, to signal or to command this generator to either increase or decrease its generation, then this change in delta p tie will be combined or will be mixed with this delta Fi inside. It will be amplified and then it will be sent no, as an output okay, to our an output of our PF controller. And so we have here the command signal delta PCI. Now, this is the command signal that go to the valve control mechanism to command this either to open or to close, partially close, okay, the main steam valve. Okay, usually for small changes of frequency and small changes of delta P, being received by the PF controller, okay, the action of the valve control mechanism, okay, due to the action of this command signal will be to partially open or partially close our main steam valve, no, not to totally open or totally close, no, this main steam valve, because of the small changes of our input, okay, to our PF controller. So with that, either additional opening of the main steam valve or partial closing of the main steam valve, okay, our turbine will receive the corresponding change the amount of steam, no, uh, due to this, okay, signal coming from our PF controller. So either the turbine will generate more mechanical power, or the turbine will generate, okay, less mechanical power. Uh, so correspondingly, the increase or decrease in the decrease, no, in the generation of mechanical power in our turbine will also be reflected as additional generation of real power, okay, to our, okay, generator. Okay, so in effect, if the turbine here increases its mechanical power, then additional power will be, okay, generated by our generator. So, okay, that is it, no? How our generator is being controlled by this power and frequency, okay, controller. Now, on the other side, we have the voltage and reactive control of our reactive power control of our generator. So again, we have a voltage sensor connected to one of the terminals of our generator. And again, this voltage sensor will compare the actual voltage measured by the sensor as against the standard voltage or rated voltage of the generator. So any difference, okay, will be then either positive or negative, now will be fed to the QB controller. So in the QB controller, this, okay, signal change in voltage, okay, will be again multiplied and then being processed, so that our QB controller will issue a command signal, which is our delta QCI command signal, which this command signal will cause, okay, our controllable excitation source to either increase or decrease the field current, no, going to our field winding. So for example, an increase, okay, in the field current will mean, okay, an increase in the flux, okay, produced by the field windings of our generator. And the increase in flux will also mean that the generator will generate, okay, higher, okay, voltage. Okay, so that corresponds to a change in voltage here, which is, okay, negative, no, meaning uh, the voltage measured here is lower than the rated voltage, and when it is processed in the QB controller, it will cause an increase, no, in the field winding current, in order that more flux will be produced in the field winding, and so therefore the generator will be able to generate more, no, to go up to its rated voltage. But if the voltage here is higher, and then when it is compared, okay, to the standard voltage or rated voltage in the voltage, okay, sensor, then we will have here, okay, a positive, okay, change, no, in voltage, because this change in voltage is the actual minus the standard or rated voltage. It's positive, and then it is processed in the QB controller, okay, and then the QB controller issue this command signal delta QCI, okay, to reduce, the field current of our field winding. Okay, so when the field current is reduced, there is also a corresponding reduction in the flux in our field poles, and so our generator will generate, okay, less, okay, voltage, at least to go back to its, okay, rated voltage. So this is how okay, our turbine generator combination will be controlled, no, by the power and frequency controller and the reactive power voltage, okay, controller. Now let us consider the speed governing system of the turbine, okay, generator. Okay, we have here the steam valve, okay, controlling the uh, flow of steam to our, okay, turbine. Now, okay, this is the steam valve, and then now we have here the, okay, hydraulic amplifier, wherein we have the piston rod, okay, connected to the steam valve and this main piston. So when we want to close, okay, the steam valve, okay, so we need to push, okay, this piston up, okay, to shut this down. So it needs, okay, great pressure, okay, applied to the main piston, okay, to bring this valve here to close, no, this throttle. And this large piston is pushed by the forced in oil, no. By the way, this can only move up when the applied force at this, okay, link, no, linkage at point D will be going down, because if we have here a force applied at point D in this direction, then this, okay, pilot valves will move down. So these two, okay, pilot valves, because they are connected together, so it will open here, but it will close here now, because when this moves down, okay, the oil cannot go up anymore. But here, because the piston, this piston uh, moves down, so there will be an opening here that will cause the oil to flow, okay, from the source of high pressure oil to towards the, okay, large, okay, cylinder. And a large force will be applied to this main piston, okay, pushing, okay, this piston rod, okay, to close, okay, the steam valve. So, okay, the oil up here, since this is open, okay, with this piston valve down, so the oil in the upper chamber of the big cylinder will just flow down in, and then exits to, okay, towards the reservoir. Okay, so that's how we can close, okay, the steam valve. Now, if we want to open, so the okay, this piston rod should move, okay, this main piston down. So that is that can be done only when the applied force, okay, will be going up here, no, at point D. Okay, so our pilot valves will be open and will be closed here, and it will be open here. So the oil from our reservoir can only flow to this, okay, going to the upper chamber of the large, okay, cylinder, okay, pushing, okay, this main piston, okay, down, okay, while since uh, the this piston rod has moved up, so this is open here, okay, so the oil, okay, under the main piston will just be drained, not towards, okay, the reservoir. So we, in effect, okay, we are now opening, okay, our steam valve, okay, because of the movement of the big cylinder here. So that's how, okay, our mechanism works, no, in shutting down, okay, our steam valve, or opening up the steam valve. Okay, now actually there are three ways of controlling, no, the opening or closing of the steam valve. Okay, by means, of course, with this okay hydraulic amplifier. Okay, the first one is by the use of the speed changer. Now, when the speed changer is brought down, okay, what happens is that okay, this point A okay will be brought down. Okay, uh, a point A will move down. So in effect, okay, this linkage with the point B as our pivot. Now when this moves down, okay, point C will move up. Now when point C will move up for this linkage, okay, when C moves up, so E will okay go down. Okay, E will go down. So meaning the piston here controlling the steam valve will move down. Of course, this is associated with okay the movement of the oil also in the hydraulic amplifier. Okay, so when this moves up, now you see that the force acting on D will also be okay up. Okay, so therefore when uh, pilot valves are pushed up, so this one will open and then this one will close, so oil will flow that way and it moves. Okay, it will push the main piston down, so it causes the motion of the okay piston rod down. Okay, thus opening our steam valve. Now notice that if we move this okay speed changer up here, we are pulling A up now. So A goes up, so with this pivot point, so C will move down, and when C will move down, and with this one as the pivot point, then E will go up. So when E will go up, so it partially okay closes our main steam valve, but it can only go up with the motion also of the okay piston in the our hydraulic amplifier. Okay, so right. So again, when we raise this or when we bring this speed changer up here, A will go up, okay, C will go down. Okay, with this one as the pivot, then E will go up, and actually, uh, in because we have here a straight linkage, then actually it pushes the pilot valves down here. Okay, with this one open and this one closed, so oil will just uh, flow through the bottom of this main piston and pushing the rod up here, no, partially closing the steam valve. So okay, it's lowering or partially okay shutting down our steam valve. Okay, now the second is, of course, this was the first now motion in the hydraulic amplifier. The second was the use of the speed changer. Now the third is with the use of the speed governor. So the flywheel governor, speed governor. Okay, now what we have here is okay, we have two balls now, and they are connected by a spring, and of course we have this okay bars or linkages to hold okay the balls together. Now these are uh, stiff okay connections okay to the balls. So when the generator is not running because the speed governor is okay, this fly ball no governor is connected to the shaft of the generator. So when there is no motion of our generator, so the spring will pull these two balls okay close together. So this will straighten up. So when the spring contracts, so these bars straighten up, and also this, so the two balls will be held okay close to each other. Now once the generator is running, okay, the balls okay will tend to fly away. Now, but since they are held by this spring and these bars here, so they can just go to a certain point. No, okay, so the balls will be uh, uh, far from each other. Now, when the speed of the generator is high, so pulling these okay connectors okay down. So when the speed of the generator is high, now with this one tendency to fly away and then pulling this uh, linkage down, so it pulls okay this point B okay down here. So when this is pulled down, it will also pull okay this okay joint no XC point C down, and when this is okay pulled down, it also pull down okay point D. Okay, and in effect okay when the okay the speed of the generator is high, then the tendency is okay because when the generator is speeding up, it means that it utilizes more steam now because more mechanical power is okay is inputted to our generator. So when the generator speeds up, okay, the tendency of the ply ball is to pull this down, okay, so that these linkages will be pulled down. So okay, when this is pulled down, so the oil here in our hydraulic amplifier will flow this way, pushing up okay the main piston and partially shutting down our steam valve. So that's how okay our steam valve can be controlled okay using these okay mechanisms.